Hi, I'm Scott. I teach freshman physics, and I wanted to take a second and share with you what I worked on this summer with my lit grant. I investigated something called Glowscript, and I'm really excited about this tool. It's a really powerful but still very simple and intuitive 3D programming language where you can use physics to animate the motion of objects. And I'm hoping that students will take the physics models that we're building in our classes and actually be able to create their own working 3D model from that. Building conceptual models is one of the most important aspects of learning physics, in my opinion. But that can be difficult because students don't always know exactly what do we mean by a model. So I think providing students with lots of different examples of different kinds of models, like conceptual models or algebraic models, or in this case, computational models, the more examples they have, the easier it is for them to understand what that is. I wanted to take a moment and just kind of share with you what I'm hoping my students will build and what could they possibly get from this. So first you can see this is all web-based. You don't have to have any fancy specialized software. On the left is the code, and then on the right is the visual output. So if I go ahead and run this, you can see it's just a ball. It's moving to the right at a constant speed. So this is our uniform motion model, which is one of the first things that we study in physics. But what I think is really cool is that the code that's creating that image is just 6 lines on the left side. And so at the beginning, I created the ball. I gave it a position and size and color. Um, I set a change in time, delta t, and I gave it an initial velocity in x, y, z form. And then this loop here is what powers the animation. This first part is just saying don't do more than 100 calculations per second. But then this part here, this is the core physics. So it's our uniform motion model. It says the new position, ball dot position, is equal to the old position plus the velocity times the change in time. And this is an equation our students see a lot in our first unit. But what I think is really cool here is that the ball actually moves, which obviously doesn't happen on a piece of paper. Um, Additionally, this software is empowering, I think, because it's really easy to make changes. So if we want to make the ball bigger and a different color, and we could also have it move in a different direction, let's say much faster. One challenge that we face, and well, I'm sure everybody else is in the same boat, is that there's only so much class time and we already have full curriculums. So my thought is that students will build these models almost entirely outside of class. I'm hoping to make a couple screencasts to kind of help them get their feet wet and learn some of the syntax, but I think it's intuitive enough that they can pretty much figure it out by themselves. And I'm really passionate about this. I think having students build a couple of these models throughout the year instead of, let's say, a worksheet or something that we might have given them instead is going to be really meaningful to them, and I think that it has a lot of potential. So thanks a lot for watching.